Okay, here we go with more CLEP calculus practice exam questions that I found online. Again, we're into this second batch here on this second exam. Whether or not you can still download it there or not, I don't know. Link in the exam, link in the description, in case it is still good, but no promises. All right, picking back up where we left off at number 15. So we have a definite integral from 2 to 5 for 1 over x dx. And so we have to work that out. First, we have to think of the, let's just rewrite it over here. 2 to 5, 1 over x dx. So what is the integral of 1 over x? Or said another way, what do you take the derivative of to make 1 over x? And if you recall, this is one of those special cases. The power rule doesn't help us here. If you try to work it out that way, I think you see why. But this is a special case where, and this is one of those that you need to remember. That is the natural log of x. So typical for a definite integral, we're going to fill in the upper bound, natural log of 5, and then subtract with the lower bound filled in. So we have the natural log of 5 minus the natural log of 2. Now, at this point, just a thing that's helpful to know about logs. Well, first let's start with none of those answers match that, right? You know it's not going to be A or B because there's no natural log in there. So that leaves us with natural log of negative natural log of 10, natural log of 5 over 2, or natural log of 3. So you think, well, 5 minus 2 equals 3, but subtraction of logs doesn't work that way, so it's not going to be that either. And what this actually is, you just have to remember this about logs from a previous math class, or if you don't, I'm telling you right now, because you are subtracting, that becomes a division. So it is the natural log of 5 over 2. And just as an FYI, just in case you want to know or might need to know, this might be unsurprising. If you are adding logs, then it does become a multiplication, and that would be 5 times 2, the natural log of 10. Right? But because we're dividing, or we're subtracting, so that becomes a division. That's how you join the logs together. So that becomes that. And that's not even a calculus thing. I think that's a algebra thing. When you learn about what you can do with the logs. So that, we didn't see too much with logs in the other batch of questions either. So that would be one of those things that, try to remember, try to keep in the back of your head. It might come up, but it's not one of those things that's going to be coming up over and over frequently. Okay, moving on. 16 we've seen before. 17 we've seen before. 18 and 19 we've seen before. So going on from there. Okay, number 20. The graph of the function f is shown in the figure above. What is the limit as x approaches 2 for the function? This is one of those classic crazy things where you have one continuous function, and then we get to x of 2, and the value at x equals 2 jumps up to way up here, and then on the other side of x of 2, it jumps back, but it jumps to a completely different place and a completely different continuous function. So this is like purely a math example thing. I can't think of any real life application of this kind of thing. But because we're not asking about the left-handed limit or the right-handed limit, if it was the left-handed limit, if it was as x approaches 2 with a minus, that would just be this one at -1. If it was from the right, from the positive direction, that would be the positive one here. But because it's the double-sided limit, x approaches 2, it is not even remotely matching from the two directions. So that's just a real easy limit does not exist. And there was another question. Do you remember the one on the previous test where it looked similar to this? It didn't have those lines, it just had those two circles. And I said, I don't know what's happening there, but we know at this point that something very bad is happening to that graph. So this is probably what that other one might have looked like, where you have something coming in from there, and then it jumps over and comes out the other side. And right here at x equals 2, all the things that you might normally be able to do on a function, you just can't do there because it's completely discontinuous. Okay, number 21. The limit as x goes to infinity for x squared over x times the natural log of x. Okay, what are we going to do with that? So again, it's as x goes to infinity, so we have to think about what happens when x becomes very, very large. And when you're taking a logarithm, and again, the natural log is the logarithm with base e, but we just know normal logarithm, as an example, log base 10 of 1,000 equals 3, because 10 to the power of 3 is 1,000. But what we can gather from that is when you take a log, what you're going to end up with is a much smaller number, because it's the inverse of taking the power. So when we're figuring how these numbers are going to compare, the natural log of x is going to be much smaller than these other x's that we have. So we can maybe ignore that. Let's see, what are we even given as options? 0, 1, 2, e, and infinity. Well, we can also figure that we do have an x squared on top and an x over the bottom, so we can cancel out the squared and we can cancel out. So we're left with x. We can say infinity over the natural log of infinity, and the natural log of infinity is going to be pretty small. So that just basically leaves us with infinity by itself. And that is indeed the answer, selection E, infinity. And yeah, again, when you do these, there's not really a lot of calculating you can do. You just have to use a little bit of guesswork, a little bit of logic. What makes sense here? What can you imagine is happening with it? What can you what can you say about it very, very simply? And that's, to cancel out an x and to figure that the natural log of the x is going to be much smaller than the other x's. And we're just left with the infinity. And the graph of that must be pretty interesting because obviously it's going up. The limit questions don't always make sense. This is not always an asymptote. It's not always a gap in a graph. This is just asking, what is it going to look like as it goes? It's a mixed bag. These limit questions are always a mixed bag. There's no consistency. All right, moving on then. Number 22, the function f is differentiable between x equals a and x equals b. And we have another x value we're calling c that's in between. So, basically we're saying there's something going on, who knows, and there's a value a and there's a value b and there's a value c in between, and it's differentiable, so there's nothing crazy happening. There's no crazy gaps, no crazy jumps. It's just a normal function that you can do something with. So which of these is not necessarily true? Okay, so if we think about it, let's look at a. The definite integral between a and b equals the definite integral from a to c plus the definite integral from c to b. So if we had this and we took the definite integral from a all the way to b, or if we just broke it into two pieces, the a to c and then the c to b, and added those together, you would get the same as the whole. Just real easy, because we know that c is in between a and b, so splitting it up like that does absolutely nothing. It's going to be the same. So that is true, so that's not going to be the answer. And then there exists a point D, another point, in the open interval between a and b. So again, just between a and b. Think it's just asking between a and b, such that the derivative of the function at that point equals the derivative of the function at b minus the a over the original b and a. So what is this telling us? This is telling us, remember the function. What is the function? So if whenever you see a function notation, f of x equals whatever with an x in there somewhere, you can think of the f of x as being the y. So when you say f of b over f of a, it's whatever the x value is at b, and then whatever the y value is at b, and whatever the x value is at a, whatever the y value is at a. So it's we're basically talking y2 minus y1 over x2 minus x1. If x and y2 is the b and x and y1 is the a, and we're just talking about the slope. This is just the description of the slope. Whatever the point is there and whatever the point is there, we don't know what it looks like. They're somewhere, but if we have the straight line slope between those points, then it's asking, is there some point in between a and b where the derivative of the function at that point, so somewhere in between a and b, the slope of the function is equal to the straight line slope between the two endpoints. And we did talk about this before. I believe it's called the mean value theorem, and you can draw out examples and try to challenge yourself to prove that wrong. But basically, you're not going to do it, and you can look up in a math book where they'll probably explain how mathematicians prove this to themselves, but it's actually pretty intuitive. Wherever this point is and wherever this point is, no matter what the curve in between looks like, at least once it has to match a slope that is the same as the overall straight line slope between those 2 points. It's just, if you look at it, if you draw it out, it's just intuitive. So it's a complex way of saying that the slope somewhere in between there has to equal the straight line slope between the two endpoints of that interval. So we know that's true. So that is not the answer being asked for. Okay. So selection C, we're talking again another definite integral from a to b of the function, and is that definite integral greater than or equal to 0? Is that a positive value? And we don't have enough information to really say that. It could be these 2 points and the function, it could be down here, and the definite integral could be negative. We've not been given any kind of information in terms of what it looks like. We just know there's some function and that we care about that function between A and B. So there's no information at all that would allow us to draw any conclusion about what the value is, whether it's more than 0, less than 0, whatever. So that is actually the answer. But let's check the other two just to be safe, just to prove it to ourselves. And so selection D asks us the limit as x approaches c for the equation is just the equation at c. And this is one of those that if there's not a gap in the graph, if there's not an asymptote, if nothing weird is happening, then the limit as you are approaching c from either side really is just whatever value is there. It's there's not even really a point in asking what the limit is. You could just say, what is the value? What is the value of y at x equals c? The limit only matters if something goofy is happening there. If nothing goofy is happening there, then you don't even really have to ask. Asking what's the limit is just the long way of going about it. It's really just simply the value of the function at that x value. So that is true. So that's not the answer that we're looking for. And then for answer selection E, it's saying if k is a real number, then the definite integral, again from a to b, of k times the function equals the definite integral of the function times k. It's basically saying that if you multiply the function by k before you take the integral, or multiply it after you do the integral, is it going to be the same thing? And if you think about that, if you have some graph, let's just do x equals y, and if we multiplied by some number like 2, so that just stretches it out in both directions, makes it higher by a factor of 2. And if we were to check the area under there and then check the area under there, you can expect that one is going to be 2 more. And it doesn't, just we can just intuitively say that it's going to be 2 more. If you calculate this one and multiply by 2, or multiply by 2 and then calculate that one, it's just pretty intuitive that they're going to equal each other. So we think this is true. So that is not the answer they're looking for. And that leaves, again, C is the only one that we can't really say anything about. We can't agree that we know that's going to be true. So we say it is not necessarily true. And that is the answer. Okay, just one more for this video. So we're going to go to number 23 here. So the integral of natural log of x over x is what? So again, this is one of those where they want you to think about the chain rule in reverse, and you just kind of gotta assume maybe it's going to be that. I think these tests really seem to love the chain rule. There's a lot more chain rule popping up than there is product rule or quotient rule. So we really have to figure on what kind of thing do we take the derivative of in order to arrive at this, because it's the integral. So it's the opposite of the derivative, so we can just work it backwards. How do we get from here to here? And if we think about it, if you notice that you have a squared here, and if you are taking a derivative, if we think of that as an x squared over 2, that when you take the derivative of that, the 2 comes down, cancels out the 2 on the bottom, and 2 minus 1, that's just x, the x by itself. And then if you think about the natural log, the derivative of that is 1 over x. So I don't know that there's a good way other than to just look at each one and envision if you had to take the derivative of that, how would you do it, and what would it come out to be? Because if that would be your g, that would be your derivative of g, that would be your f, that would be your derivative of f. So again, the derivative of f, just the x, so you're taking the original g, the natural log of x, putting into there, and then multiplying it by there. So you're just left with the natural log of x over x, which is what we have there. So yeah, I don't know there's a good way to do it. The reverse chain rule is just kind of half intuition, half trial and error. You just have to think about where things are going to come from. You know that the derivative of natural log of x is the 1 over x, so you think, well, maybe that's where that x came from, so you wouldn't have started with an x on the bottom. And if it's one of these, you have that squared, and if you take the derivative of x squared, the 2 comes down and eliminates the half, and it just works out that way. If you tried it with these other ones, it's not going to work, but if you try it with C, that does what we're looking for. So that is the answer to that one. And yeah, there's not a rigorous, there's not a way we can go straight there. You just kind of got to feel it out and maybe take a guess. You know, if you're pressed for time, maybe skip that one, go back to it. Or if you can just kind of intuit, you know, maybe it's that one, and then work it out and notice, take the derivative of that with the chain rule, you get what you started with, and so it's going to be that. And okay, number 24 is also duplicate, so on the next video we will pick up with the following page.